Because if we're saying, hey, we're building a website that lets you do travel stuff, and we don't know where we're going to get that travel stuff, well, that's something we need to figure out. Howdy, folks. Today I wanted to talk about what it takes to architect a project. Um, it not necessarily code, though we might go into some of the code here because that's also kind of interesting. But what does it mean to actually design a project and really think about that design? Now, most of the projects that we pick up, that we start, we don't do a lot of design. We're just like, oh, I want to build a travel website, or I want to build this little game, or I want to build this small thing because they're little, right? And we add on to them as we go on, and then we need to refactor later on. And refactoring is a skill. It's definitely a valuable thing to know how to do, but it also takes time. And if you can know and really plan ahead and plan your project ahead of time, then you can really avoid a lot of that refactoring. Let's get into it. So today I want to take a look at a Wordle project. And I have a person I'm working with right now who is currently building a Wordle project for various other purposes. But we have run into the issue where it's gotten a little snarled on some of the data stuff, and I think it could be improved a little bit. So let's talk about kind of how we might do that. So let's think a little bit about the steps that we would need to actually design this project. And this would be before we get into the code, way before we get into the code. Just what does that look like? So I feel like this is too, that's okay. So the first step that we're going to want to do is figure out what data we need. Any program, any website, application, game, phone app, anything, basically boils down to data manipulation. Think about it, right? Just think about it. The UI around that data manipulation might be complicated. It might entertain us. It might show us the data in a certain way, but it really boils down to data manipulation. So we have data. We want to do something to it or display it in a certain way. And the user can give us ideas or things to do with that data and possibly new data. So the first thing we need to do is figure out what data we need. What is the application going to do? Okay. And then we need to figure out what data we have. So data we have doesn't mean, oh, I just have a spreadsheet with all this data, though sometimes it does. What data we have essentially means what data can we easily get our hands on. If it's travel data, for instance, what do we have an API for that? If we're adding a feature into an existing system, what data already exists? So sometimes this is small. But the thing between these two pieces, okay, what data do we need? What data do we have? That tells us what data we need the user to provide, or we need to figure out where we're going to get it. Because if we're saying, hey, we're building a website that lets you do travel stuff, and we don't know where we're going to get that travel stuff, well, that's something we need to figure out. So let's look at Wordle. So Wordle, for those of you who are not aware, is a game where there's a word. I can't remember, it's 5 or 6 letters, but essentially you guess, and then it tells you which of those guesses were good. This is just like that. So then if I do that, I know, okay, the A and the T exist. And it uses colors, and basically you're supposed to kind of guess based on slowly the words or the letters and the positioning and what letters are not in the word, what your sample word is. It's a decently simple game, but people seem to be really happy with it. So what data do we need for this? Okay, well, we need words. Okay, we have guesses. Okay, that's cool. We would have a game of Wordle. We would have users. I'm not really talking about how these are interconnected right now. I'm just spitballing like what these data pieces actually are. Okay, words, guesses, games, users. Anything else? I guess that's good for now. Let's just leave that for now. Okay, so now what we need, okay, what we have. What do we have? Well, words. Okay. Words we can have big list of words. ChatGPT can do this. You can find on the internet. There's plenty of these. Okay. So then things get tricky because we know where that comes from. Okay. Game. The game is something that we know what it looks like, but we kind of don't. We can generate it ourselves, I guess, is a thing. Like, we don't need a user technically to create a game. We could create a game with a user, and that's what we're going to do, but we can create this as needed. That's right. So that's data that we don't hard code that data, but we're going to create it. Okay, so what about guesses? Come from user. We don't put these ourselves. These come from the user. Okay, users. We need creation flow for the users. Cool. So here's kind of, I guess, what we have is maybe a little bit more like, where is the data going to come from? But I like what we have because it fits nicely with what we need. So here's what we have. Here's where we're getting this. Now let's talk. What do these look like? Words. So let's say now database tables. And this gives us a very important question here. How are we going to store this data? Where are we putting this? Or actually, maybe let's just do that. Does it live? Words. We could do a couple things with the words. We could do text file, database table. So what's the benefit of each one? Well, a text file, very simple. Text file. You just include it in your repository. You check it in. It's good to go. With your database table, that gives us more flexibility, though. That gives us, if we have admins, maybe, if we have user submitted words, it also attaches an ID to a word, which gives us the ability to reference it more easily. So let's say we have maybe a user wants to create a specific kind of game with like maybe 10 specific words. If we've got them on the text file, we have to actually reference those words individually. So here's all the words just as strings, which is okay, but it means that the data is a little bit duplicated because those word strings are everywhere. And also, it means that if we ever change a word, the word doesn't get updated. Now, technically, we shouldn't actually ever be changing a word. That's data that would mess up a bunch of stuff. But database tables make things a little bit more flexible. It gives us the ability to programmatically change our stuff. Text files technically do too, but it's just a lot harder. So, but that's our options, right? Maybe we go with text file first. Okay, so game, this is going to live in the database. Okay, guesses, database, and users, database. Cool. What database are we going to use? That's the next question. What database? And this in the end just comes down to NoSQL versus SQL. You can get more granular with it. Like, am I using Couchbase? Am I using Mongo? Am I using Redis? Am I using Postgres? Am I using MySQL? But the differences between those things are not large. The differences between all the NoSQL databases, and yes, I know there are differences between them, but the bigger difference is relational versus non-relational, SQL versus NoSQL. And yes, Mongo can be relational, Couchbase can sometimes be relational, some of these other ones can be relational, but it's not what they're designed for. So a NoSQL database is really good when we have a lot of data that has a bunch of different format. And it's not always going to be the same format, or we have a really complicated nested blob that we don't really, we want to look inside that nesting, and it's just, there's a lot of stuff in there, and we want to be able to update it to have different formats. So if the format of your data could change or is going to be really nested, and you don't really care so much about that nesting on the data layer. I mean, obviously we're going to care about the nesting, but maybe on the data layer itself, you don't necessarily care about that. That's what NoSQL is very good for. Document stores, key value stores, things like that. SQL, on the other hand, is very good when you have static data, not static data, but static format of your data. To a point, you can do SQL with non-static, but it doesn't work super well with it. And your data needs to relate to each other very strongly. This is why, honestly, even in this day and age, people pick SQL databases a lot. I am going to go with a SQL database. Most of our data is relational. Game probably relates to words, guesses, and users. Users relates to game. Guesses might relate to users. Words relates to a bunch of stuff as well. We have tables that interact with each other and relate to each other, and we may need to be doing complex lookups on that. And so relational is very good for that. And also this data doesn't change much. Once we've got the format of our data, we're probably not going to be changing that. Or when we are changing that, we're going to be doing it as part of a project or a feature. It's not going to be something we're doing dynamically. So now, let's look at our data formats. So our game table. I'm not going to be putting, let's just say, assume ID creation. So I'm not going to be putting these fields in here. We just assume we have that. A game. What is a game? A game of Wordle, okay. Well, it has some guesses, okay. But the game itself, and this is the weird thing about SQL, the game itself is going to have multiple guesses, whereas a guess probably only belongs to one game, so we're not actually tracking them here. What I could do, though, I could just say, hey, the guesses are here, right? I'm not actually writing the table right now. I can do whatever I want. Guesses, okay, we have a user, we have a word, okay. That's a very simple game. We can infer from this whether or not the game is over, because we know there's a certain number of guesses we can have. And if we've made that many guesses, well, game's over. We could also infer from the guess itself might know if it's correct. So we could also infer if the game is over if there's any correct guess. And so you can see here already, I'm thinking about what kind of data does a game care about? Well, maybe I'll say here. One. I'm extrapolating these, right? I'm not storing this information on the game, but it is still information about the game. What is next? We've got, oh yeah, word. Okay, the actual word string. That's kind of it. The word doesn't really need a lot of other stuff right now, which is why it's really easy to keep it in the text file. User, username, password, email. We don't even need to know here games played. Or sorry, we do need to know here, but we can extrapolate. Oops. And games won. And lost. This is the beauty of using a relational system. I don't need to store how many games I've played because I can just look that up. Games won for that user, I can look that up based on the game table and the guesses. Okay, so then what's the next thing? I'm missing one table. Guesses. You notice these I'm actually was using like more of a plural, and here I'm using a singular. It's totally up to you which one you want to do. The guess has a game. Okay, attached to the game, it has a user that made the guess. Do we need this? We might. There's a thing that the game technically does belong to a user. Okay. The guess also belongs to a user. So we don't really need both because we've got that triangle now. The game knows what guesses it has, and the user knows what guesses they make because they know what game they're in. So I'm going to do some interesting here, and I'm actually going to get rid of that. A game no longer belongs to a single user. Why did I do that? Why would a game ever not belong to a single user? I don't know. But the idea of your data structure is you want to make it as flexible as possible. This means more code, and there are situations where you say, no, this is ridiculous, I don't want to deal with this. But if I attach my guess only to a user, okay, that means that I could possibly in the future have a game that multiple users are guessing on. That could be kind of fun, right? Wordle with your friends. You have a single word, and you all maybe make a single guess on it based on each other's guess and go round robin. That'd be kind of cool. I don't know if I'm going to do that, but I don't want my data structure to preclude me from doing that. I could actually even have, if I wanted to, users on a guess, like multiple users that could make a guess. That might be good. I could do a many-to-many table on that. That could be interesting. Maybe I'll go with that. Maybe I'll just say like user many. Am I ever going to use that? I don't know. Is it going to make my code complicated? Yeah. But the whole point here is that I'm making my data structure and I don't know the decisions I need to make in the future, so I'm trying not to block myself into a corner. And then also the actual guess of the user. So then we need like correct counter. Well, let's see. So we need to actually store something a little complicated here. Of the word, we need to know what letter positions were correct and what letter positions were the letter is here but in the wrong place. So we actually might want a more complicated thing here. We might want, so here's my guess, my full guess. Actually, I don't need that. Let's do guess entry. Well, guess entry is a bad name, but I'll come back to that. So this is going to be the position, the actual guess object, position, correct, and this is going to be like something like 0 correct, 1 correct, 2 wrong, place, something like that. So now what I have is if I guess I have after, this actually goes to a single guess, but it has 6 entries or 5 entries, and each one has the position, the actual guess letter, and whether or not it was correct, not correct, or in the wrong place. I could use an enum for this too. Now you see this is already more complicated, but this also gives me the ability to extrapolate whether or not it was correct, which is important, but it also gives me enough data to know the positioning and stuff. And I could do some more complicated inner thing here, and guess might actually want to be a NoSQL table for that case. I could see getting away with that, but because I didn't pick a NoSQL table before, this is kind of how I have to do this. So this is kind of the process you want to go through. These are all the things that I need to have on here. Okay. I don't know why after was in there. So there's one more table that we want, and this is kind of the kicker. How do I know what a game is? Well, normally a game of Wordle would be, I'll do this down here. 1 user, 6 guesses, 5-letter word, 24 hours. Okay? So you get 1 word every 24 hours. It's a 5-letter word, you have 6 guesses on it. There's no reason that I need to put this in the code, right? I don't need to hard code this. So I could also have my game settings table, which actually knows the game it belongs to, user count, guess count, word letter, and let's see, oh yeah, we can also only have 1 word per day, or reset. So then we could have words per day and reset in seconds. Why seconds when I'm doing 24 hours? Well, that gives me a lot of flexibility. I could have something that resets every 10 seconds. I could have something that resets every 2 weeks. Putting it in seconds is just the lowest granularity I can go to, which allows me the highest amount of flexibility. I build this in, and then I just have 1 entry with default game, right? So maybe I actually have game type. Yeah, let's actually do this. Let's call it game type. And then we'll come up here in our game. We actually have a game type it belongs to. Now that means that my game now has a bunch of different options. I could allow the user to set this. I could allow the admin to set this. As long as I put this in the code, I may never even expose it, but it's there. That functionality is there. And this is kind of the thing we want to look at, is how many of your settings, how many of your things can you put into data? Because the more things you can put into data, even if you don't actually utilize them as data initially, it gives you the ability to change them later on very easily without having to redeploy your code. And that is kind of the thing we're striving for. Anyway, I hope this is interesting. In some later videos, I'll talk a little bit more about how we handle the code for this and how we do some more modularity. But this is it for now. Have a good one, folks. See you next time.